Hello viewers, in today's session we are going to discuss another important and conceptual problem from limits involving the signum function and greatest integer function, right? So here we have to discuss this limit, that is limit x tends to 2, and here we have the signum function of greatest integer of x minus 2, right? So here the square brackets denotes the greatest integer function. So here we have to see whether the limit of this function when x approaches to 2, it exists or not, right? So for this, what we will do, we'll find out the right hand limit and the left hand limit. So let us start. So now we know that for the existence of limit of a function at a given point, both the right hand limit and the left hand limit should be finite, and both these limits should exist, right? And moreover, if the limit of the function is to exist, then both these limits should be equal to each other, right? So first we'll find out the right hand limit of this function, right? So let us take the function f of x as signum of greatest integer of x minus 2, right? We'll also define the signum function, and here we have the right hand limit. The notation is limit x tends to 2, and here we put a positive sign, and here we have f of x, right? So here we have x is equal to 2. So when we find out the right hand limit, then we approach towards x is equal to 2 from the right of x is equal to 2, and we take a point in the right neighborhood of x is equal to 2, and this point is 2 plus h, right? And when we find out the left hand limit, then we approach towards x is equal to 2 from the left of x is equal to 2, and we take a point in the left neighborhood of x is equal to 2, and this point is 2 minus h, right? So when we calculate the right hand limit, then we take x is equal to 2 plus h, and this quantity h is a positive quantity, and it lies between 0 and 1, and h is infinitesimally very small, right? So when x tends to 2, then obviously h tends to 0. So now we can express this limit in terms of h. So we have limit h tends to 0, and here we have f of x, and x can be replaced by 2 plus h. So now f of 2 plus h can be obtained by replacing x by 2 plus h in this function. So we have limit h tends to 0, and we have signum of greatest integer of 2 plus h minus 2. So now we can write limit h tends to 0, and here we have signum of greatest integer of h, because this 2 and this 2 get cancelled, right? So now we have to find the value of greatest integer of h, and we have already said that this quantity h, it is infinitesimally very small, but it is positive and it lies between 0 and 1, right? So from the definition of greatest integer function, we can see that when h it lies between 0 and 1, then the greatest integer of h should be equal to 0, right? Because the greatest integer of h that is less than or equal to h is this number, that is 0, right? So here we have the greatest integer of h as 0. So now we have limit h tends to 0, and we have signum of 0, right? So now we can omit this limit sign here. So we can simply write signum of 0. And we know the definition of signum function, that is signum of p is defined as plus 1 whenever p is greater than 0. Signum of p is 0 whenever p is equal to 0, and signum of p is minus 1 whenever p is less than 0. Right? So here we see that the value of p is 0, so signum of 0 should be equal to 0. Right? So the right hand limit of this function f of x when x approaches to 2 is given by 0. Right? Now let us find out the left hand limit. So the notation for the left hand limit is given by limit x tends to 2, and here we put a negative sign, and here we have f of x. So now we take x is equal to 2 minus h, because in this case we are approaching towards x is equal to 2 from the left of x is equal to 2. So all the values of x should be less than 2, right? And when x approaches to 2, then h tends to 0. So now writing this limit in terms of h, we can have left hand limit equal to limit h tends to 0, and here we have f of x, x is 2 minus h. So now we have limit h tends to 0, and f of 2 minus h can be obtained by replacing x by 2 minus h. So we have signum of greatest integer of 2 minus h minus 2, and now this 2 and this 2 get cancelled, and we have limit h tends to 0 and signum of greatest integer of minus h. So now here we have a signum of greatest integer of minus h, and we have to first write the value of greatest integer of minus h. So what we will do, will make use of this inequality, that is h lies between 0 and 1. So multiplying this inequality throughout by minus 1, we have 0. The direction of the inequality get reversed, so we can now write minus 1, then minus h, and then 0. Right? So minus h lies between minus 1 and 0, while h lies between 0 and 1. So the greatest integer of minus h should be equal to minus 1. Right? So now the left hand limit is given by limit h tends to 0. We have signum of minus 1. Right? Now since this term is independent of h, so we can now remove this limit notation. So we have simply signum of minus 1. Now see, we have defined signum of p as minus 1 when p is less than 0. So here p is minus 1, which is obviously less than 0. So signum of minus 1 is equal to minus 1. Right? So the left hand limit is equal to minus 1. Now we can see that both the limits, that is the right hand limit and the left hand limit, both exist and they are finite. But these two limits are not equal to each other. So the right hand limit is not equal to the left hand limit, because 0 is not equal to minus 1. So we can say that the limit of this function when x approaches to 2, it does not exist.